Hello everyone, I'm Manlin Chu from TAL Education Group. It's my honor to share our solution for homemade scene graph generation task on behalf of our team, IALAT. Our report contains 4 parts: task description, our solution, experimental results, and summary. The first part, task description. It firstly gives us videos of daily activities at home. The goal of scene graph generation is to predict object categories and infer relations between the person and each object, including how they change as the video progresses. For example, in the frames below, the object is ointment. The relations between the person and ointment in the first 2 frames are holding, looking at, and in front of. As time goes by, the relation between the person and the ointment in the third frame becomes twisting instead of holding. The evaluation metric is the average score of recall 10 and recall 20. Recall K means the fraction of times the ground truth relationship triplets are predicted in the top K most confident relationships predictions in each tested frame. This slide shows the information of the dataset. In the training dataset, there are 2,560 valid videos and more than 100,000 valid frames. The number of object categories is 84, and the number of relation categories is 25. This chart shows the proportions of different numbers of relations per pair. We can see that the proportion of 3 relations per pair accounted for the largest proportion, and the proportion of 1 to 3 relations per pair has reached 97%, which means the number of relations per pair is usually less than 3. We sample 308 videos as our validation set according to the official support. For the test dataset, there are 140 videos in this competition. It's different from the previous competition of CVPR. Our solution is divided into 3 stages. The first stage is the classification stage, which predicts the category of the object. The model we choose is Swing Transformer. The second stage is Relational Reasoning stage, which infers the relationships between people and object. The model we choose is ICG. And the third stage is the post-process stage. Next, we will introduce these 3 stages in detail. In the first stage, the champion team used the detection model in the previous CVPR competition. Considering that the bounding box of objects is given in the dataset, we experimentally verified the results of using classification model and the detection model. The classification model we use is Swing Large, and the detection model we use is Cascade RCNN-based Swing Large. The experimental results show that the accuracy of the classification model is higher than the detection model. The accuracy of classification is 75.29%, and the accuracy of detection is 72.8%. So we finally chose the classification model in the first stage. This slide shows our optimization of the classification model, including hyperparameter adjustment, data augmentation, frozen swing transformer block, and TTA. The results of our experiments are listed in the table below. The accuracy of our baseline is 75.29%, and the final accuracy is 80.33% after the optimization-based single model. The ensemble method of classification we used is the weighted averaging, We integrated 4 models, including swing large, efficient net V2, C-swing large, and VIT large. The final accuracy of a classification is 81.81% after ensemble. The second stage is relational reasoning stage. The framework we used is ICG, and the backbone is replaced with swing large for better feature extraction. The third stage is post-process stage. The goal at this stage is to convert the output of ICG into the final result. This slide shows the strategies we used. We first adjusted the threshold of score to control the number of relations and get a higher recall, which is benefit for the generation of relation pairs. We use the simple combination method to generate relation pairs between people and object. And the class-wise based prior relation knowledge is used in our method. That is, weight the score of relation pairs based on the frequency of relations under the condition of a person and the specific object. It can be seen from the table that the score without prior knowledge is 56.3%, and the score with prior knowledge improves 75.5%. This is our final experimental results. The first table is the result on the validation side. The score-based single model is 75.5%. The score of the ensemble is 76.7%. The second table is the result on the test site. The final score in the test site is 75.15%. To summarize, we use a 3-stage method to solve homage scene graph generation task, which achieve 75.15% accuracy on final test site and rank the first place in this challenge. We show that a classifier predictor is better than detector in this task. And we combine prior relation knowledge to further enhance the ability of relational reasoning. That's all, thanks.